Hey guys, today we are going to use angle-angle similarity to show that triangles are similar, and then we're going to use similar triangles to solve some real-world problems. So the angle-angle similarity postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are congruent. Okay, so here I have angle K is congruent to angle Y, and angle J is congruent to angle X. Now you may remember way back in Unit 4, there was something called the third angles theorem that said that if two angles of one triangle are congruent to two angles of another triangle, then these third angles are also congruent. So if I have two sets of congruent angles, that's enough to actually know that I actually have three sets of congruent angles and that the triangles are similar. So here, triangle JKL is similar to triangle XYZ, and they are similar by the angle-angle similarity postulate. Okay, so are these two triangles similar to each other? And if so, we will write a similarity statement and say why they are similar. So I've got right angles here and here, so I know there's one set of congruent angles. But then I've got a 68 here and a 22 here. So let's find the measure of angle A. So that would be 180 minus 90 minus 68. And that is not correct. Let's try that again. 180 minus 90 minus 68 is 22. So this angle right here is 22 degrees, which matches this one here. So these are congruent angles. So I've got right angles, which are congruent to each other, and 22-degree angles, which are congruent to each other. So I can say that they are similar. So triangle ABC is similar to triangle. Now I need this in corresponding order. So A is 22, that corresponds with D. B is a right angle, that corresponds with E. And then F and C are both going to be 68-degree angles, so C corresponds with F. And they are similar by angle-angle similarity. I have found there to be two congruent angles at least, which means the third is congruent also. So that is angle-angle similarity. Okay. How about these triangles? Are they similar? So let's find the measure of angle Q. 180 minus 71 and 78. And that is 31 degrees. So I have a 78 here and here, a 31 here and here. Two angles congruent, that's enough to say that triangle PQR is similar to triangle, okay, P is 71, that would be H. Q is 31, so that goes with G, and R is 78, that goes with F. So there's my similarity statement in corresponding order, and they are similar by angle-angle similarity. Okay, are these triangles similar? Let's find angle F. 180 minus 110 and 27. And that is 43. So this is 43 degrees. So I've got a 27 and a 53, and I've got 110, 43, and 27. This one has a 53. This triangle does not have a 53, so I'm going to have to say these are not similar because this one doesn't have a 53 like that one. All of the angles would have to match, but this triangle does not have a 53, so they are not similar. Okay? How can we show that these triangles are similar? So I've got triangle RTV. So that's this triangle up here. And then I've got this outer triangle, RQS. Now they both have a 49-degree angle. Okay, but I need another angle to show that they are similar. But they actually share an angle up here. They share angle R, and the reflexive property says that something is congruent to itself, anything is congruent to itself, and since they share angle R, I can say angle R is congruent to angle R, so that gives me a pair of congruent angles here, and then a pair here, so I have angle-angle similarity. So triangle RTV is similar to triangle RQS by angle-angle similarity. Okay, here I've got one pair of congruent angles. How can I show that these two triangles are similar to each other? Well, I have parallel lines here, and here's a line that intersects both of the two parallel lines, so that's a transversal. And on a transversal, between parallel lines, corresponding angles are congruent. These are both in a top left position here. These are congruent to each other because they are corresponding angles on parallel lines. So that gives me my two pairs of congruent angles. So triangle LMN is similar to triangle NOP by angle-angle similarity. Okay, now how about these triangles? I've got a pair of right angles right here, so those are congruent to each other. I also have a pair of vertical angles here, and vertical angles are always congruent to each other. Okay, so I've got my two pairs of congruent angles. So triangle BCD is similar to triangle EFD by angle-angle similarity. So here's a lifeguard standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall, and the lifeguard's shadow is 48 inches long. So the chair casts a shadow that is 6 feet long. How tall is the chair? So if the shadow is going this direction, that means the sun is somewhere up in this area, and its rays are coming down like this and like this on the chair and the lifeguard, and it would be forming the same angle right here. Okay, now the lifeguard is standing straight up and the chair is straight up and down, so that is a right angle. So I can say that these two triangles are similar by angle-angle similarity. And we can use proportions on these similar triangles to find out how tall that chair is. So we have someone who is 6 feet 4 inches tall and casts a 48-inch shadow. So 6 feet 4 inches is to 48 as what is to 6 feet? Okay, now I think this would be easiest if we set everything in inches. So 6 feet, 6 times 12, okay, and we can use a calculator for this. 6 times 12 is 72. Okay, so it's 72 inches. Oh, plus that 4 inches. So it's actually 76 inches is the height of the lifeguard. 76 inches is to 48 inches. So a 76-foot tall person casts a 48-inch shadow. How tall of a chair casts a 6-foot shadow? And 6 feet, we know already, is 72 inches. Okay, so let's do cross products. 48x equals 76 times 72 is 5,472. Okay, and then let's divide by 48. So divided by 48 is 114 inches. So the chair is 114 inches tall. Now, let's put that into feet and inches like we have here for the lifeguard. So let's divide that by 12 to get it into feet. and it's 9.5 feet. So the chair is 9.5 feet, which is 9 feet, and then 0.5 feet, that's a half of a foot, so 6 inches tall. So there is the height of the chair. So in that example, how long is the shadow of a person who is 4 feet 9 inches tall? Okay, so we can compare either the chair to this person, or we can compare the lifeguard. Let's compare the lifeguard to this person. So we have a lifeguard who is 6'4", which is 76 inches, and casts a 48-inch shadow. Okay, now this other person is 4 feet 9 inches tall. So 4 times 12 is 48 inches. So 4 feet is 48 inches plus those 9 inches. So this person is 57 inches tall. How long is the shadow? Okay, so we'll do our cross products. We have 76x and 48 times 57 is 2,736. Okay, and then we can divide. Okay, and we find, let's see, so we're dividing by 76. We find that the shadow is 36 inches long. Okay, so the shadow of this 4 foot 9 person is a 36-inch long shadow.